Hi everyone, I wanted to start with a quick personal story. A couple of weeks ago, I got into an argument with my parents because I turned off my location on a night out with my friends. And then for me, having them see my location at all times feels like very invasive. It becomes a reason for them to question where I am or be like, why are you at tap at 1 a.m. and stuff. But at the same time, I also have a younger sister, which I do care about. And having her location helps me feel like she's safe. So I see both sides of the story where one wants privacy, but also wanting protection. This inspired basically inspired my project. I wanted to explore whether there's a way to use probability to detect unusual behavior or unsafe behavior without constantly tracking someone or judging every small movement that they make. So instead of watching every step, what if we only flagged the moments that are truly out of someone's routine? And so once I started building on this idea, I realized that it could be used for many other real-world issues. For example, people with dementia often wander at night, unexpectedly at night, and then families want to monitor their children without using strict or invasive rules. In parole systems, where the goal is to detect genuine unusual behavior instead of punishing every minor movement someone makes, this could also be important. And then finally, in disaster situations where patterns suddenly change and responders need to know which areas show abnormal movement, this could also be very important. So this motivated me to create a probabilistic model that detects location-based anomalies. It only uses mathematical patterns rather than using constant surveillance. Now let me explain how the project works. Because I did not use real GPS data, I created a simulated data set that took 30 days of location points, and then each point had a timestamp, a latitude, a longitude, and then a label showing whether the person is at home, at work, or at the gym. I also added a small probability points that are supposed to be unusual. You can see this here at this here. And then I assumed the normal locations, home, work, and gym, each behave like a Gaussian distribution. So the model learns the center of each location cluster, and then it also learns the typical spread around each place. So the time of day also matters here. At night, the person is usually at home, and then during work hours, the person is usually around the work cluster. And then in early evenings, the person sometimes goes to the gym and sometimes not. Once in a while, I add anomalies that are points that are far away from the normal routines. So next, I fit the Gaussian models to the normal data only, and then the program computed the mean and the covariance for each cluster. Then for every new location, I calculated its log likelihood, basically how typical or probable the point is under the learned model. If the score was too high, as you can see here, if the score is too high, the movement if the score is high, the movement is normal. But then if the score drops very low, that means that the movement is extremely unlikely, which is hence why these X's are here. The anomaly points are the ones that are the X's, by the way. And then to flag the anomalies, I set a simple threshold, which is any point that is in the lowest 1% of likelihoods is supposed to be considered unusual. This is what helps avoid invasive tracking, and then basically tracks the behaviors that do not match the person's routine. And then as you can see on this spatial plot, the flagged anomalies appear far outside these clusters. As you can see, each one is supposed to be home, work, and then gym. And finally, I added a Bayesian add-on that basically sees how often anomalies happen during the day versus during the night. And then I basically used a beta binomial model to compute the uncertainty around these rates. This part isn't really required for the model, but it just gives extra context to help us think more carefully instead of jumping to conclusions. So basically, if nighttime anomalies start increasing, it means that someone with dementia might be in danger, and then it might it signals that for someone with dementia that they're in danger. And then if daytime anomalies start to rise for a parole case, it means that their routine has shifted in an expected way. To conclude, the project basically started with my own personal conflict about privacy and safety, and then I was able to build a system that detects unusual behavior using a mathematical and respectful way. Thank you for listening, and I hope you enjoyed the project.